Today I will be talking about X64 debug, which is an open source 64-bit and 32-bit debugger made for Windows. And despite the name 64-bit, it is available for both 64 and 32-bit. Uh, so some reasons you might do this is it's under active development and it's updated a lot more than other debuggers like Ollie or WinDebug. You can make plugins for it using C++. And all around, it's just a more graphics-based experience than what you might find with something like WinDebug, where you have to memorize a lot more commands. That's useful to a lot of people. And another thing about this is it's made with security in mind. So if we just look at the developer's Twitter page, you can see they're posting about how it's featured in books about malware analysis, and they're talking about looks like different exploits here that people have worked on using this debugger. So a lot of features for it are very useful for security. So I guess a good place to start would be how to actually install it. And pretty simple, just on the home page here they have a download button. It'll take you to their SourceForge page. And when you click this download, it will just give you a zip folder, and you can just unzip that into a directory anywhere, and that's basically done. So to launch it, you'll go into release, and then X32 will give you the 32-bit version, and X64 64-bit. Or you can also do, here it's called X96 debug.exe, which will give you the options for both, and just a quick setup, and it's just a few questions about how you want it configured. This isn't actually necessary, but can be helpful. I already have desktop shortcuts, so I'll say no for that. And it's pretty much done. So to start off with, I'll just show a few basic examples in the debugger just so you can see how it works. So first, to get the executable into the debugger, it'll just depend on what kind of software you have. It's like something like this where the process is only active for a fraction of a second. When I start it, you'll have to open up the executable directly. So you just go into the debugger, File, Open, name of the executable. Then you can see that it will launch it directly into the debugger, and then it will start it paused because it will insert a system breakpoint right away. So the other way you can get your executable into the debugger. It's a situation like this where the software is actually going to stay open and stay active. There might be situations where opening it will change the behavior of the software. So you'll want to start the process normally, and then you go to attach, and then just double click the name of the server, and then it will again pause the program. So then I'll just go through some of the tabs up here. So the CPU one is just general information about the state of the process. So you can see on the side here you have all of the registers with their values. And then if the value in the register is an address, it will tell you some information about what that address is. And you can also double click on any of these values. You can directly change what is stored inside the register. And then for the flags, something useful to know is if you hover over them, it will tell you a little bit about how the flag is used. And then the same thing about FS, they'll tell you that it's the tab. And then it just has a lot of the other registers that you won't use as much. So if you want, you can hide that. These will be used in a lot more specific ways that you might not always care about. So next up is uh, the actual instructions. So one useful thing to note is when you click on one of these lines here, it will show you which register is being modified. So return only modifies ESP, no operation modifies nothing, calls is ESP, move EAX1 will change the value in EAX. So that can be useful to learn more about how these operations work. Then other than that, it's pretty much just standard disassembly. So next we'll go to this dump tab, and that will allow you to dump sections of memory. So what we can do here is go to EDX, which has a valid address, hit dump, and then it'll show us exactly what is there in memory. So if we go to ESP dump, that'll show us the contents of the stack. Next we have graph. So if you go here to CPU, right click on one of these instructions, you can hit graph. Then that will show you a graph similar to IDA of the program. Then log, if anything does go wrong, log it. Then the breakpoints. So the way it handles breakpoints is a little bit different than WinDebug. So in WinDebug, you would type the address. Here it's all graphical. And so you would right-click, breakpoint, toggle, and it'll set a breakpoint there. If we go back, then you'll see it's there, it's enabled, the disassembly at that address, how many times it's been hit. So then to disable it, you would just click again, or right click and toggle it. So next up is memory map. This will show all of the memory in the process, what's contained at it, what protection it has, what type. So here we can see this is the memory where our executable is stored at. So if we actually double click on that, it'll bring it into the dump, and you can see this is where the PE file is, which makes sense with what we see here in the memory map. That the PE file would be there. Then we have call stack. Pretty self-explanatory. Again, we can go. So we can right-click, hit follow. Then that will bring it up in the disassembly. Then we have the CEH, structured exception handling. For each of these, we can hit follow handler, and that'll take us to where the exception will be handled. Script will be for running scripts, which I don't have any right now. Symbols will show all of the modules within the program. So we can see Vault server here, which is we're running. You can see the export is just the address of entry point, or the .exe, and we can see everything that it's importing here. So npdll.dll, that's going to have a lot more exports for all of the functions that it provides. And lastly, we can look at the threads. If the program contains more than one thread, you'll be able to view both of them. And then finally, we have handles, which if we had a more interesting example, there would be a lot more like TCP connections and different like file handles and that sort of thing. So everything I've mentioned so far about X64 debug has all been GUI based. I should also note that there are text-based commands available, and these can be useful sometimes. So in their documentation, they do have a full list of all of these commands. So if we go to general purpose, you can see here what it actually allows you to do is test like assembly instructions. So we can take like push, for example. And you can see there we were, after running this push command, it pushed our value to the stack. So that could be useful in some situations. But I think what is better to use the command for is the breakpoints. So many times in writing software exploits, you will get an address from something like IDA, and instead of trying to find it in here, what might be better is just to do breakpoint and then paste the address in from IDA or Ghidra, wherever you find it, and then hit enter. You can see here it activated the breakpoint of that address. And also in this view, it shows us the breakpoint. So I think that's just a little bit better than how I set breakpoints before, but either way is both valid. So then there's just a lot of commands that allow you to get very advanced with this debugger, but I'm only planning on going through the very basics right now. So for the last portion of this video, I thought it might be useful to actually see an exploit in action through this debugger. So the target will be Easy Chat Server, which has been shown in class before. So we'll just get that started. And then open up the debugger, attach Easy Chat, and then we can hit run. You can see it is running, and it is in fact working as expected. So then I'll just open up the exploit script that I have already created. So the first thing I'll do is comment out the actual payload of it, and just pretend that we found this buffer overflow, and we're just seeing how it reacts to a large amount of data. So 500 A's in this case. So now that the server is running and everything, we can just run that script. And then you will notice that it automatically paused because it encountered an error, first chance exception at this address, exception access violation. So we can see the EIP where that happened. It's trying to move ECX +4, or the D word, at ECX +4 into ECX. And ECX right now is filled with A's, so that is not going to be a valid memory address. And you can actually see here that EAX has a pointer, and whatever is in this, whatever is being pointed to at this location is all filled with A's, which is our payload. That happens in a number of cases. So then we can also look at our call stack, and it's a similar situation, all filled with A's. Look at SEH, and we can see that the handler here and the address here were both also overwritten. So that gives us a good idea at how this can be exploited. Then the last thing for this example is we'll go to ESP and follow and dump. This will show us the memory of the stack. And we can look in here and we can see the entire payload on the stack. And so now I'll show it using an actual payload. So instead of doing the whole process of getting it attached, we can just hit restart and it'll just restart the executable exactly as we had it running before. And then we can hit run. And as you'll see here, for every entry point in the program, it will put in a new breakpoint. So now we'll click through the trial information. And normally the software would just start, but you'll see here that it paused again because it had another entry point at NTDLL. So we can hit run again and hit another one and another one. So that's one of the things I don't particularly like about this debugger, is that it enters a lot of breakpoints that I don't always feel are useful. Anyway, now you can see it is up and running again. So now let's pretend that we did the work of actually figuring out what should be in this payload to actually exploit the server. And save that and just run that again. You can see another exception breakpoint caught here. Then we'll just do the same thing, look at, we'll start with the call stack. You can see here again, it's filled with B's this time, which corresponds to what we have in the script. But if we look at SEH this time, we'll see in the handler address from our script here. So that tells us that this has been overflowed correctly. And then we'll look at the address field here, the 909006 EB, which corresponds exactly to what we have here. So that appears to be working right. Then we'll look at the stack one more time. right click, follow and dump. Then we can see on the stack here all of the B's to overflow, EB0690, the shellcode, and then finally the D's that we have at the end here just to make sure there's enough data as part of this payload. So now that all of that looks like it's in the correct location, we can just hit run again. So it hit one more breakpoint that I didn't actually look at too closely. But you can see here that the exploit did work, a calculator did spawn. Another useful thing to learn how to do in this debugger is how to change the command line arguments. So what you can do is you just have whatever executable loaded either through directly opening it or attaching it. So you can see this one will take some arguments, and without them, it'll just terminate the entire process. So you can restart it, go to File, change command line arguments. Then the first one in quotation marks is the path to the executable. Then right after that, you can start typing the arguments. And then OK. We'll save that. And then so this time, you can keep running it. And this time the exploit does actually work because it has the proper command line arguments.